So like yesterday, we're going to lead off with a lot of definitions. I'm sorry, that's just the way it is when you start a new thing. And then we'll go into some problems. Hopefully we'll finish a little early, and I'll give you some time to practice, because we're going to have a quiz on these first two sections tomorrow. Okay? All right? We're going to have a quiz on these first two sections tomorrow. I want to quiz you before you go to spring break, because then everything just disappears. So definitions. Definitions. First off, a central angle. Central angle. If it's too small, please move up. There's plenty of room up here. A central angle is an angle whose vertex is the center. All right, makes sense. Central angle, the vertex is the center. Remember, the vertex is where those two meet. Okay, where the angles meet. The point. Alicia, go. An example. Draw a circle off to the side. We'll use this for all of our examples right now. We'll call it with center A. A central angle, a good example would be like this. Here's B, here's C. So notice how it's still an angle, but that its center is right in the middle. So an example here would be angle CAB. Okay? Angle CAB. Notice how the vertex is in the center. Darren? What do you mean to say? Yeah, kind of. Although that talks about a different thing. Okay. A minor arc. Minor arc is an arc that is less than 180 degrees. And you ask what an arc is. Well, arc is walking along the edge of the circle. It's the distance along the edge of the circle, okay? Yes, ma'am? Say that again? The arch? That's from my hometown. St. Louis, Missouri. It's not really like that, though. All right? I like that you refer to my hometown, though. Thank you. So a minor arc is less than 180 degrees. So an example of this is right here. This is a minor arc. We'll talk about the 180 issue in a second. To name it, you use the endpoints. So what are the endpoints of this arc? Well, they're B and C. Does that make sense? When we do it just like we have line BC, we write BC next to each other, but instead it gets a fancy hat, instead of just a flat brim, right? It's going to have a little curved baseball cap, just like the arc, okay? Does that make sense? It seems logical. The other way we could also name it would be CB. Doesn't matter, as long as you show that it's a curved arc. Any questions on those? Okay, still? The next one is a major arc. A major arc. A major arc, well, if minor is less than 180, major is greater than 180. So I'll show you in a second. We use 3 letters to name a major arc, okay? If I haven't given you 3 letters, you want to take always the shortest path. Always take the shortest path when possible. So in order to name this major arc, I need to actually add another letter. I'm going to add letter D over here. Doesn't matter really where D goes as long as it's on the other side. So if I wanted to name this major arc, which goes the long way, everybody see how it goes the long way around the circle? We need to use 3 letters. We need to use 3 letters. We still use the same endpoints, so we can still name it CB. But in the middle, you also have to put one of the points that it goes through. So you see how we travel along? It's going to go through point D. Okay? You need to add that 3rd letter, because if you just put CB, it's going to think you're talking about the minor arc. So always take the shortest route, unless they give you a place you have to go in between. So in this case, we need to go through D on our way. Does that make sense? Like you got to pick up D on your way to your friend's house.
Does that mean dollars?
The other way, what else could I name it? What else could I name it? Marshall?
BDC.
BDC, very good. So major arcs are always going to have 3 letters. The last one we need to talk about is a semicircle. Semi means half, so a semicircle is half a circle. A semicircle is an arc with endpoints that are the endpoints of the diameter. A diameter cuts a circle in half. Diameter cuts a circle in half. Okay? So if this is my diameter, everybody see the diameter? I'm going to double up here. This is my semicircle. Notice that it's half the circle. Semi means half, or 2. So a semicircle measures exactly 180 degrees. And how would we name that? How do we name it? Marshall?
Would it be DB?
DB with a little arc on top. Okay? How do we feel about those? How do we feel about those? So once again, use the endpoints. Always take the shortest route unless it tells you to go through somewhere else. Okay? Always take the shortest route unless, like in this one, it tells you to go through point D on the way. Minor, less than 180. Major, greater than 180. Semicircle, exactly 180. The whole circle. How much would the whole circle be? 360. Because you think two half circles are both 180, so the whole thing has to be 360. Also think of it, if you're spinning around, it's going to be 360 degrees. All right? Now the next question we have to answer is, well, this is great. How do we measure them? All right. You guys, we got to pick it up. Come on. I know it's a lot of writing, but let's go. No. No, I'm not going to. Sorry. I promise this is the most writing we're doing today. The first section is always the worst, okay? And then we're just going to do some example problems. That won't be bad. It's all the ladies with your pretty handwriting. You got to make it look good. Actually, I have pretty handwriting too. I much prefer grading for women. Ready?
Yeah.
Sorry, get it from a neighbor. Measuring arcs. Measuring arc. The measure of a minor arc is the measure of its central angle. Yep, we are on the bottom. Measure of its central angle. Perfect?
No.
And that was pretty good.
It's not even connected. Like.
We'll call it circle E. If I draw a central angle, where does the vertex have to be for a central angle? Center. So we'll connect. I just missed. All right. Try that again. Wow. So if we draw our central angle right here, we'll call this A and B. If my central angle is, let's say, that looks like 50 degrees to me. Alright, that looks like 50 degrees to me in there. the measure of your arc then is the same as the measure of your central angle. That's its definition. So if I'm talking about the minor arc, which I'll highlight in blue here, if I'm talking about that arc, the measure of the arc, the measure of the arc AB is equal to the measure of its corresponding central angle, which is angle AEB. Do you see how the central angle matches up with that arc? It makes like a pizza slice with it. Well, they're both equal, so how much does the arc have to be then? It would be 50 degrees. So arcs are measured in degrees, so that would be 50 degrees. The measure of the major arc, major is bigger or smaller? Measure of the major arc is the difference means add or subtract? The difference between 360 degrees, which is the whole thing, minus its related minor arc. Minus its related minor arc. What that means is if we're looking at the major arc, this guy, I need to add a letter over here so I can name it adequately. So we'll call this B. So that means that the measure of my major arc, how would I name that arc? Ariel, please pay attention. How would I name that arc, Nicole? The major one? ADB, good. It's going to be equal to 360, which is the whole circle, minus the piece we've already taken out of it. Well, what have we taken out? 50. So it's going to be equal to how many degrees then? 310. So this is going to be 310 degrees. So remember, the whole thing is how many degrees? 360. If you already have the small piece, you can figure out what is left for the larger arc, the major arc. Questions with how to understand arcs or measure arcs? Rochelle. How are you going to what? Perfect. Next slide. Sorry, I'm just anticipating. Okay. So far, just most of the definitions. Now, a problem that would show up on your quiz. Oh, no, one more slide. Sorry, I forgot about this one. Sorry. The arc addition postulate. Arc addition postulate. We had this. Don't make me do it again. We had this before when we had A, B, C. This was 3 and this was 5. How much is the whole thing? 8. Because we knew that AB plus BC had to equal the whole thing, right? Part plus part equals whole. Do you remember doing this?
Yes.
The same thing is true for arcs. I have two arcs. The measure of an arc formed by two adjacent, which means next to, arcs is the sum, so we add them together, of the two smaller pieces. So if I have the red one, the red arc, AB, the green arc, BC, and I want to find the blue arc, all you have to do is say that the arc AB, the measure of it, plus what? Good. The two small ones added together equal the big arc, which is measure of arc AC. Why don't I need to put the B in that case? Why can't I just say AC instead of ABC there? Hang on, raise your hand, please. Ariel? A and C are the endpoints, I agree. Be a bit more specific. Darren? What do you mean by that side? Correct. Maybe, Patricia, a little bit more.
Because it's a minor arc, so it has to be less than 180.
Good. AC is a minor arc. That means it's less than 180, okay? We always assume that you take the shortest path unless it tells you not to. So AC, is that the shortest path, or would you rather go all the way around? It is the shortest path, so that's why we can just leave out B, okay? If it weren't the shortest path, we would have to add in the middle letter. All right, so here's the question you guys had from before. We got just 2 slides, quick practice, and then we'll be pretty much done, I think. All right? So first, quick practice. Let's classify each one as a major arc, a minor arc, or a semicircle. Then it says to find the measure of each arc. Let's do just this part first. Let's just do major, minor, or semicircle. And then I'll show you guys how to find the measures of each one. So, arc DE. Major, minor, semicircle. Raise your hands, please. Devon. So semicircle is formed by the half a circle. Where is DE?
B.
There's DE. Is that major? So it's bigger than half a circle? Is it minor?
Minor.
Minor. So DE is going to be minor. What about arc CF? Arc CF. Maria? Semicircle. What is CF called? The line.
What, you mean like that?
Yeah.
Isn't it a chord? No.
It is a chord, but we can be more specific because it goes through the center.
Radius, diameter.
Diameter. Radius is half of it. Diameter is the whole thing. Let's make sure we know those by tomorrow. Okay. Arc. BDF. BDF. Julian? Major. How do you know, Julian? It's 3 letters. That's one hint. The other thing is, if you notice, we start here, we go to D, we keep going to F. That is more than half of the pizza, right? See how it walks around more than half of it? So it's got to be major. BC, please. BC. Lino. Minor, very good. And EDF? EDF? Marshall?
It's a minor.
Why?
Because it's less than 180.
So, where do you want me to start? I'm going to put my pencil. E? Do I want to go to the left or the right? So I go to D, then where do I need to go?
Like, go in the middle, go in the middle.
Is that what we discussed as the arc?
No.
Did the arc go through the middle? You have to go all the way around. So I want to start at E. My next point is D, but then I have to go all the way to F. So that is almost the entire circle, right? That's going to be a major. Okay? Now, what I want you to do is to find each arc measure. 3 hints here. So 3 hints. Remember that the semicircle is equal to 180 degrees. So the semicircle is 180 degrees. All right? Also remember to look for vertical angles. Vertical angles are congruent. What that means is vertical angles are wherever you see that X, and they're opposite one another. Okay? They're going to be vertical. So whenever you see them, they form the X. All right? So, let's take a look. I think before you do this, I would ignore this completely. Just find each arc with your shape. Then you can go to this and add or subtract as you need. Okay? So I would say let's find these missing ones. First off, what is arc DE going to be? If this is 81, what's DE?
81.
Good. Whoops, that didn't work.
Angle FE and DE.
So this one will be 135. Are we cool with that?
Yeah.
All right, who wants to start me off here? What can we do to start us off? Ratio?
If you look at CF, you know, I mean, it's my circle.
So we look at CF. We know it's a semicircle.
And so you subtract 81 from 180,
So this whole thing is how much?
180.
180. So we do 180 minus the part we've already found to get this piece. Oops, sorry. To get this piece right there. Does that make sense?
Yeah.
So what would BC be then?
45.
45 degrees.
And FE is congruent to DE.
Erase this real quick. Now, you should notice, yes, right away, if this is 45, then the central angle has to be 45, right? Do you see the vertical angles here across from one another? So they're equal, so what does this have to be?
45.
And so what's the arc have to be?
45.
And how many unknowns, how many arcs do we have left? 1. How much do they all have to add up to? So could you figure out that missing one?
Yeah.
Alicia, do you have it? You may. Want to show? 54? I agree. The other way you could have done it, you could also look at that semicircle and say that adds up to 180. Okay? How do we feel about those? They're just kind of like those puzzles where you have a bunch of angles and you just find them all.
Yeah.
Right? Same type of deal. Arc DE, what is DE? Once you get all of them, go back to this, and then it's going to be pretty easy. What's DE?
81.
81 degrees. What is CF?
180.
What is CF?
180.
180. That should be really easy. It should be for everybody. Semicircle is how many degrees? 180. BDF. BDF. If you want to do BDF, you're going to go all the way around.
Or you could just subtract 530.
2 ways you can do it, yes. Add them all up, or 360 minus what's missing. So 360 minus 135 is going to give you
125. No, 225.
225. Does that make sense? How it's once you get all these angles, it's easy to get this stuff. BC 45. And EDF. EDF. What's the piece that's missing from EDF?
45.
Sorry. Here's EDF. We go E to D all the way to F. So what's the part that's missing? 45. So we do the whole thing, which is minus the missing piece. So you get 315. Okay? Are those easy enough? Okay. I had another one. We're not going to do it, but I just wanted to point out one thing. What does this measure mean? What does that mean? They're congruent. So these two have to be equal to each other. That's the only real tricky part. Yes. The only other thing they might give you a circle where you have that. What does that mean? So this would be 90 degrees. Okay? Easy enough. All right? Very simple. Okay? We're not going to do this one. Congruent circles, congruent arcs. No, we'll skip it. I just want to tell you. Congruent circles, circles with the same radius. You don't have to copy it. Circles with the same radius. That just means that the circles are the same size. Okay? So circles are the same size. Alright? Congruent arcs are arcs with the same measure and they have to be from the same circle or for congruent circles. That means they have to have the same measure, like 45 degrees, and they also have to be on the same size circle. So it can't be like a huge one versus a small one. It has to be 45 degrees on the same size circle. Okay? They very rarely come up, though. All right? Your homework for tonight, I want to write that down. Here's your homework. We'll have a quiz tomorrow. That is the world's tallest bridge.
Really?
Those are clouds.
Wow.
And that is in France.
We should go there.
I believe it's in the Loire Valley.
You jump in, guy.
I don't know. They wanted to connect. There was a big valley in between these two towns, and they wanted to connect them directly. So it cost a lot of money.
That's the first thing that's gonna go,
Air pressure would get lower, but I mean, people have been up to Everest, which is the tallest thing on Earth.
Well, that are people crossing.
I don't know. I've never done that. Your quiz. Write down your homework. I'll switch it in a second. Write down your homework, please. You got 10 seconds, and then I'm gonna switch it. Your quiz is on 10.1, 10.2. Today after school, the Georgetown tutors will be here. I have a 4 p.m. meeting, so if you want my help, come early. All right. I've had meetings all this week, and doesn't make me happy either. Yes.
Okay.
So, quiz tomorrow in class. We're going to do a little practice worksheet for 10 minutes here. Maria? They only come on Wednesdays and Thursdays, although not tomorrow, because it's our last day. Wednesdays and Thursdays. They cannot come on Mondays. Oh, I'm sorry. Javier, I accidentally just wiped it free. I'm sorry.